All right, well, welcome everyone. I am JJ. Let's tackle an example problem. So in this one, we're saying let's reduce the single force here at point B and our couple moment acting on our beam to a single force. And we're told to locate it a horizontal distance D from our point of B. So I could either move this to the right or I can move it off the edge of the beam to the left. And we'll come in and work with that. Let's go for it. So all I need to do, I need to have the same tendency to translate and to rotate this object. So if I'm getting rid of that couple and leaving it with just a force, by default, I'm going to have the same tendency to translate. I'm not changing this force in here. My sum of the forces will be the exact same. I need to come in and figure out then, how do I get, I'm just redrawing that beam. If I'm moving that force over, I could either, I'm starting here at B, come over here and find some distance D, or it might be off the edge of our beam, some distance D. We need to figure out what is this distance that will get us a clockwise rotation of 308 Newton meters. So we can start an equation here. 308 equals, actually before we do that, let's come in and say, we need to figure out which direction is it? Is it this D moving to the right or this one moving to the left? To do that, well, I know my moment originally was clockwise, so as I move that force over, if I move my force to here, am I going to get a clockwise moment? Or if I move it over here, am I going to get a clockwise moment? And we can just check that. Either way, that x component, if we sum moments about point B, is going to get us no moment. Its line of action passes through. The y component on the left side here, if I pin at B and I pull down, I'm going to get a counterclockwise rotation about B. I need clockwise to match that couple moment I'm replacing. On the right side here, if I pin at B and I pull down, I do get a clockwise rotation. So I need this one on the right, is what I'm saying with all of that. So let's erase this side. I know when I set everything up, I need to get a clockwise rotation out from this. Moving my force to the right is going to get that clockwise rotation. So I can label this. This is 103.5 newtons, and my angle here is 45.5 degrees. From there, we can then come in and start trying to get an equation that would solve us for D. I know a moment is force times distance. I'm only moving this horizontally. I'll never, even if I move a mile off to the side, I'm never going to get a moment from the x component in here. So it's really just the y component. So I can say my moment from that y component has to equal the couple moment that I'm replacing. 308. 308 Newton meters going clockwise has to equal a clockwise rotation from this force. So force in the y, 103.5 sine 45.5 times, I need a perpendicular distance that it's moving, D. And we're just going to solve for that distance D to figure out where to locate this at. So I can just divide by 103.5 sine 45.5, and I'm going to get here that my distance D is 4.17 meters. So if I move that force over, D equals 4.17 meters. That this object here, even though I've gotten rid of that couple moment altogether, is going to have the same tendency to translate and rotate. Externally, looking at the supports here, we have an equivalent object on that. These two things we would say are externally equivalent to each other. That's really all we have to that. Figure out which direction to move everything based on the rotation of our original object and solve for a distance D. And our problem statement should give us which direction, like horizontally, vertically, at a specific angle. Hopefully it doesn't tell us to do that one. We need to move everything. But you can get through these. Good luck with them. If this video was useful for you, hit your like and subscribe button. And we'll stick around and get an A with JJ.